Okay, guys, welcome to the one where we're talking about segments. So we talked about lines last time, but we didn't really talk about segments. So let's talk about what that is, and then we'll talk about kind of the math we're doing with it. So, um, segments, unlike a line where a line goes infinitely, segments stop on both ends. So it's a measurable part of a line. So for example, segment AB right here. We can count and see that it's one. It's kind of small on my screen. There we go, I'm blind. 1, 2, 3, 4 units. So we'd write a 4 right there. So you could write AB like that, or you could put the little line over it like you did a line, except no arrows on the ends because it doesn't keep going. Congruent segments. So congruent is like same size and shape. So basically for a line segment, if they have the same length to them, then they're congruent. So we know that one already is 4, so I could count 1, 2, 3, 4 units. I know AB and CD are congruent. What that could allow me to do is write AB equals CD. CD. And then what we could do with that is later we have an equal sign now. Now we're talking equations. The segment addition postulate is basically like a rule. You could think of it like that. That says that if we know the length of AB and we know the length of BC, so this part right here, if we know that, and if we know this, we can add them together and we know the whole thing then. So basically if I know the length of the two parts, I can add them together and get the whole thing. Similarly, we could say, what if I know the whole thing in just AB? I could subtract AB and my remaining amount would be BC. So we can kind of set this up here. Let me see if I can write on the screen. I don't know if it'll let me with a PDF. Ooh, okay. You guys are learning at the same time as me. Can I hide this? Okay. We'll see how this goes. Might not end up using it. So for these first ones, it tells us, for example, PQ, so it's referencing this picture, is 9, QR is 28. So let me see if I can write a 9 on here. It's kind of big, but whatever. And 28. It wants to find PR, so what is the whole thing? I kind of missed at the end there, but pretend that's lined up with the R. Basically, the segment addition postulate means I can add those together and get 37 and say, boom, that's the length of the entire segment. Where it gets a little bit more challenging and you have to think back to Algebra 1. Hopefully you had a good Algebra 1 teacher or someone to teach Algebra 1. Is when it comes into having variables. So for example, number 3 here says EG, so it's referencing the entire thing, is 71. Find the value of X. So we know the entire thing equals 71. We might not actually solve the problem, but I can show you how to set it up. Well, we know the two pieces add together to give you 71, because that's what the segment addition postulate does. So here's my first piece, 8x minus 17, and I'm going to run out of space, I think, but we'll try to squeeze it in there, plus 5x minus 3, good enough. And now I have my two different pieces added together, equals what it told me was the total, 71, and then I could solve this for x. So just start thinking combining like terms. So like the x's go together, the constants, a negative 17, negative 3. Try to get x by itself, we'd solve from there. And then obviously, you know, if you need algebra help, you could look back on, I think I have past videos on equation solving. Let's see, let's keep going because these are kind of the same idea. Let me see if there's any that stick out to me. If TV, let's talk 4 real quick. So the difference with 4 here is that my total has a variable in it. So if I have one chunk, so that's TU, plus this other part, UV, equals this. It's still equation solving, but now you have variables on both sides. So you would want to combine that 2 and 5, and then get all the x's to one side, all the constants to another. So just wanted to show that real quick. Let's keep going. How do I get this off the screen? There we go. That's not what I want yet. Here we go. Midpoint. Let's bring my drawing tool back up here real quick. Okay, I think we're good. So midpoint is exactly what it sounds like. It's the middle point on a segment. So for example here, I have segment AC. B is the midpoint because it directly sits in the middle. How is that useful? Well, notice these little kind of tick marks on those. Those identify two things as congruent, meaning that they're the same length. So if I have let's pretend AC is 10 units long. Well, if I know B's in the middle, then AB must be 5, BC must be 5. So it cuts it in half. So in terms of using that mathematically, notice here it doesn't say like this chunk plus this chunk equals this. It just says Q is the midpoint, find the value. Well, that's because it's assuming we know how midpoints work now, is that the two segments are equal. So we could set up something that looks like this and solve kind of like I just showed before, get all the x's to one side, all the constants to another, and then you have your value of x. And then if you really wanted to, if your teacher told you to, you could plug that x back in and actually get a full number for each segment. And if you did it once, you would already know what the other one has to be, assuming you did it right, because it's a midpoint, one side has to equal the other. So I think we'll stop there for this one. Feel free to comment if you got questions or anything, and we'll see you guys.